So on to question number 5. Okay, so these are one of the fun ones. Question number 5, specify the reagent you would use in each step of the following synthesis. You start off with this alcohol group. It reacts with something to get an unknown product, then reacts with something else. To get a new carbon bond formed here. And you also want to keep this alcohol group on the same carbon. So 1, 2, 3, 4, 1, 2, 3, 4. So we're looking for this intermediate, and we're also looking for the different reagents. Okay, so let's just look at the reagents that are available, and then we'll try to do process of elimination. So let's see, they give us a lot of these. Every time you have like a carbon group that's with magnesium and bromide, this is something called Grignard's reagent, and it is a helpful way to add a new carbon group to like aldehydes. So we know that we're gonna need one of these Grignard reagents in step 2. So in our case, we need one that has a phenyl group, so we can rule out this methyl, ethyl. Okay, so we're gonna need this one as our reactant in the end. So it is C6H5MgBr. And usually this is reacted with like an acid. This is something called the Workup Step. Just to get a feel of what this compound looks like. It's basically this phenyl group that has the magnesium bromide attached to that. Okay, so we know that this is what we need in the second step. But in order to get from this intermediate to there and react with this Grignard reagent, then this middle group needs to be an aldehyde. So this is because after this aldehyde reacts with the Grignard reagent, this carbonyl group gets reduced back to the alcohol that we started with, and then you see that there's a new carbon-carbon bond that is formed. And so now we just need to figure out how to get from this alcohol to the carbonyl group. So I'll go over all of the reagents that are given in case it just looks like a lot of random compounds. I'll show you what they all mean. So this lithium and aluminum hydride is actually a strong reducing agent. So basically you would use this to form alcohols. So we can rule out that. H2SO4 is usually for the elimination of OH with heat. So we don't want to get rid of our alcohol group, we want to kind of keep it on that carbon. So we're going to rule out that. HCl is an acid. Typically when it's reacted with an alcohol, it replaces it with a Cl group, sorry. And the same thing goes, or sorry, skipped HBr. Yeah, similarly, HBr does the same thing, except you replace your OH group with bromine. SOCl2. That's a similar thing with HCl, except it takes into account the stereochemistry. So you get an inversion of stereochemistry. So this question doesn't even ask about stereochemistry, so we can just rule out that as well. And then similarly, this PBr3 does the same thing, replaces it with Br, and there's an inversion of stereochemistry. And finally, we have something called pyridinium chlorochromate, also known as PCC. So this is actually what we're looking for here. So PCC is what will oxidize our alcohol group to the carbonyl. So that's done, but I'll still go over the rest just to finish it off. This is a base that will deprotonate the alcohol group. And it's used to form ethers. The NaOH. It also reacts, it's also a base. It tends to form aldehyde enolates. And it does that by reacting with another molecule of aldehyde. So this is something called the aldol reaction. And I'm going to skip all those Grignard reagents, sorry. And then lastly is Chromium Tri Oxide. So this is something that you would use for Jones oxidation. So this is a very strong oxidizer, and it will convert your OH all the way to carbon hydroxide, or ketones if it was in the middle. Okay, so let's see. The answer says here, step 1, pyridinium chlorochromate. Step 2, phenyl magnesium bromide. Solution is correct.